Welcome to Homework Lib.
For this problem, let's remember that the cryoscopic constant is going to be equal to 1.86 degrees Celsius kilogram per mole in the case of water. So we're told that the freezing point of a 0.1 molar solution had a value for delta T of approximately minus 0.27 degrees Celsius. We want to know if this corresponds to the molecular formula of a mercurium nitrate or mercury nitrate corresponding to HgNO3, or for the Hg2 2 plus ion, which would generate NO3 2 to balance out the charges. Let's compare these two compounds when they are dissolved into water, assuming complete dissociation. The first one would have a Van-Hoff factor equal to 2, and the second one would have a Van-Hoff factor equal to 3. So, in order to know what is going to happen, let's find the Van-Hoff factor coming from our calculations. We're given that the molarity is equal to 0.10 molal solution, right? So, remember that delta T is equal to minus Van-Hoff factor times cryoscopic constant times molality. So, the Van-Hoff factor is going to be equal to minus delta T of freezing. Let me put freezing all over the place, divided by Kf times the molality. In this case, the Van-Hoff factor corresponds to minus 0.27, minus this value over here, so 0.27 degrees Celsius, divided by my cryoscopic constant, that is 1.86 degrees Celsius kilogram per mole, and on the denominator as well, 0.1 mole per kilogram. So you can see the units are going to cancel out, kilogram, mole with mole, and we're going to end up with a value of 1.45. So what this means is that the correct molecular formula is the first one, but something is going on with the mercury ion. So what is happening is that HgNO3 is going to dissociate in water to produce Hg plus NO3 minus. I'm going to put a 2 in front of it just to continue the following reaction. And then what is going to happen is that the Hg plus ion is going to associate together to generate Hg2 2 plus. It is going to dimerize. So from the first reaction, the Van-Hoff factor would be equal to 2. But since a portion over here, alpha, is going to associate and generate a dimer, the value is going to be a little bit smaller than 2. So in this case, the mathematical way to look at it is that the Van-Hoff factor is going to be equal to 1 plus the fraction that is going to dissociate. Let's call this alpha dissociation times n minus 1, when n is the number of ions. And we're going to subtract the factor alpha of association over 2. What happens here is that if alpha of dissociation is equal to 1 and alpha of association is equal to 1, for this case where the number of molecules generated would be equal to 2, according to our initial reaction over here, what we would get is that the Van-Hoff factor is going to be equal to 1 plus 1 times 2 minus 1 minus 1/2, which would be equal to 1.5. So, as you can see, what is happening here is that almost all of the compound is going to dissociate, and almost all of the mercury is going to associate to produce Hg2 2 plus. That would be all. Thank you very much, and have a good one.